Hello, and welcome to part 2 of the one sample t-test video. This should be fairly straightforward and fairly short. Today we're going to be talking about confidence intervals. Essentially, they are an estimation. So since we have, since t-tests, be it one sample, independent or dependent, although right now we're covering one sample, so don't worry about the other ones I said, that comes later. But with t-tests, we are dealing with, again, the sample mean, and we have more information on the sample. So we have the sample standard deviation, the t-distribution itself, and the t-table all refer to things of a sample. So we don't know the population mean like we do for z-scores, for z-tests. So what we do is we have to estimate that. We're estimating our population. So in order to do that, we have to use confidence intervals. So we do estimations a lot. We make estimations all the time. We can say outside right now, it's between 60 and 70 degrees. Or, oh, there's about 20 to 30 people in this class. Or, oh, I have a budget of, I'm setting a budget, I'm going to go out tonight, although that's not as fitting in COVID times. But, I don't want to spend any more than $100. I need to pick up I need to go to Target. I need to get dish soap and laundry detergent, but I need to make sure I spend between $50 and $100 because it's Target and I can't just get what I need. In fact, I'll get other stuff and probably forget what I need if you're anything like me. But these can be seen as interval estimates. We have two numbers in which we kind of estimate the range of. So, okay, temperature right now is between 60 and 70 degrees. Actually, oh my God, it is 68 degrees right now. So I would be correct in that estimate, but it's an estimate of, between 60 and 70 degrees right now. That's what it feels like in the wind. I don't know. There's between 20 and 40 people that are registered for this class, or I want to spend anywhere between $50 and $100 at Target, or what have you. Those can be seen as interval estimates, and we do them fairly often. So we do the same thing in statistics, except instead of calling them interval estimates, we call them confidence intervals. And we'll get into that right now. Oh, if I can find my mouse. There we go. So confidence intervals is a range, or the interval, again, between one number and another, of possible values that the population is likely to be contained in, the population parameter. The true population of our sample is going to be somewhere between X and Y. So anytime that we calculate confidence intervals, keep in mind that you are going to be calculating two numbers. You should, once you're done with it, once you say, okay, I got my confidence interval, you should have two numbers. Oh, we're 95% confident that the true population mean lies between 10 and 20, or between -7 and -2, or whatever your confidence interval is going to spit out. But you should always have two numbers. Just like how the weather outside is between 60 and 70 degrees, your confidence interval should be between one number and another. So anytime you have confidence intervals, you're going to end with two numbers. So here is our formula for that. Here's how we calculate it. So we take our sample mean, which is that italicized M, plus and minus our critical t value from the table, times our estimated standard error. So what we do is we just multiply the value we find in the table for the t-test that we're conducting, using all the information of our significance, our degrees of freedom, and if it's a 1 or 2 tail test. We get that critical value from the t-table. We calculate our estimated standard error, and then we multiply those two numbers together. And we're going to both add that number and subtract that number from our sample mean. That'll give us two numbers. Okay, so to do it, first we got to find the sample mean and the estimated standard error. Then we have to choose the level of confidence and find the critical values at that level. And then we just use the formula that you've seen before and find those two numbers that provide us a bracket of it's between X and Y. So it's fairly straightforward, fairly simple. So this is what the example we had For the previous lecture on one sample t-test, so the one you probably just finished watching or have watched up to this point, I don't know your life, but you've likely seen it already, or at least looked over the PowerPoints. So with that, we had the, we were looking at the relatives of people who cared for patients with OCD. So the population mean was 77.43. The sample size was 18. The mean was 62. And since this is a one sample t-test, the mean for the sample was 62. And since it's a one sample t-test, we have the standard deviation for the sample as well at 20.94. And our alpha is set at 0.05. Okay, so this is the information that we need to get our to calculate our confidence interval. Step one, well, we have our sample mean that was provided to us at 62. Now we have to get our estimated standard error, which we've also calculated, but this is just a refresh. So our estimated standard error is going to be our our sample standard deviation divided by the square root of our sample size, which was 18. And we have an estimated standard error of 4.94. Bitchin', cool, nifty, neat. Step one's done. We've already done step one when we've calculated our one sample t-test from before. Now to step two, where we determine what level of confidence that we have. So in order to know what level of confidence we have to know the level of significance that we have. We have to know alpha. Now, alpha is typically set at 0.05. So with that, our level of confidence is going to be 95%. They add to 100. So, 0.05 is also 5%, if we were to convert that to a percentage. So just add that. Whatever you have to add to 5% to make it 100 is going to be your level of confidence. So you have a 95% confidence interval. If our alpha was set at 0.01, we would have a 99% confidence interval. If it was set at 0.10, that would be a 90% confidence interval. And if it was set at 0.2, we'd have a 80% confidence interval that we were working with. But the fact of the matter is, the level of confidence that you have, that percentage of 99, 95, 90, 80, whatever, that is determined by alpha. And again, it has to add up to 100 to where that's how you know. So whatever you have to add to your significance value to make 100, that's going to be your confidence interval. So 0.05 is what we're working with. 95% confidence interval is what we also are working with. So step two's done. We know we're going to have a 95% confidence interval. Now let's actually do the equation. So we have our sample mean plus minus our critical value times our estimated standard error. Well, we have all of that information. Our sample mean was 62. Our critical t value was 2.110. That was from the t table, where we looked at the degrees of freedom for 17. Since our sample size is 18, we do n-1 to get our degrees of freedom. We have a two-tailed test at alpha set at 0.05. So that's the information we use to calculate our critical values. So that is just 2.110. And the estimated standard error, we've calculated that already. So first, let's multiply our critical t value by our estimated standard error. So 2.11 times 4.94 gives us 10.42. Now let's take our sample mean. So we've done this so far. We've done this part. We've done that, 10.42. Now, what we got to do is take our sample mean, and we have to do both the plus and minus for it. So we have to do 62 plus 1042 or 10.42, and then we have to do our sample mean minus 10.42. So we got to do 62 plus 10.42 and 62 minus 10.42. And that gives us the upper and lower boundaries of our confidence interval. So once we've done that, pretty much what we say is we are 95% confident. Again, we know it's 95% confidence because we did because of step two. We know since we have alpha at 0.05, that's a 95% confidence interval. So we are 95% confident that the true population mean of relatives of patients with OCD, so this is the sample that we're referring to, that we are making inferences about the population, not just the sample, but the population with our one sample t-test. Now we're saying we're 95% confident that the true population mean of relatives of patients with OCD is between 51.58 and 72.42. So that 51.58 was obtained by taking our sample mean minus the critical t-value times the estimated standard error, and that 72.42, we calculated that by taking our sample mean plus our critical t-value times the estimated standard error. So I mentioned how when we calculate confidence intervals, when we're done with them, we should have two numbers that we have calculated, and here they are. So we're 95% confident that the true population mean of our sample, which was relatives of patients with OCD, is between 51.58 and 72.42. That is the two numbers that we obtained, and we did that through this formula. So, I mean, I told you it'd be a short lecture. That was just, you know, we're just tacking on confidence intervals with that. Keep in mind, we do that because with t-tests and t-distributions, we don't know the true population mean. We're having to estimate it. So we have that confidence interval there to say, we're 95% sure that the true population mean of the sample, again, this is the population mean we don't have in a one sample t-test. We're 95% confident that the sample of the population of the sample that we have in this problem is between X and Y. And that is what a confidence interval is telling you. If you have any questions, as per usual, email me, send me a message through Canvas, or come to my office hours. I'll be happy to discuss anything with you. But that's all I got for you today. So, you know, stay breezy and like and subscribe. Pew, pew.